Hi, I'm Mr. V, and this is our fourth lesson on Similarity, Unit 3, where we're going to be talking about the side splitter theorem. By the end of the period, you should be able to say, I can explain why a segment that that crosses through a triangle, is parallel to one of the sides, divides the sides that it intersects with into proportional parts. And I can use proportional parts to solve problems. So the first thing is to notice and wonder. And what some of the students have said is they notice that there are some arrows here. They notice that these two lines are parallel, AC and MN. MN is a shorter segment than AC because they both connect at B. Some people have said, I notice a triangle and a trapezoid. Some people noticed that they have two triangles here, a small one and a large one. They notice that these railroad tracks means that the lines are parallel. And when you write the symbols, you have arrowheads on these, the tops of these to indicate that they're lines. One person noticed that they notice that this angle, CAB and MNB, are congruent because they are alternate interior angles formed by the transversal AB crossing the parallel lines. The same with angle C and angle MNB. Both of these angles are corresponding. One person noticed that they have angle B is congruent to itself, and it's in common with both of the little triangle and the big triangle. Some things people wondered. I wonder if M is a midpoint. I wonder what this has to do with similar triangles. If MN is doing this side splitting, how does this deal with this particular problem? And when we look at this, we say, so a line passes through a triangle that's parallel to one side. Does it always create similar triangles? And I want you to find information that is true, that can be backed up with a rule, and mark it on the drawing. So, for instance, don't say that M is a midpoint unless you know you have evidence to back it up. Well, it looks like a midpoint is not evidence. And then I want you to make a conjecture based on this first statement. So the conjecture that you're going to make, or that you should make, is if a line passes through a triangle that is parallel to one of the sides, it will always divide those sides that it intersects with into proportional parts. And notice that this says nothing about the sides that are parallel to each other. It only talks about the ones that are being split. That's why they call this the side splitter theorem. And the evidence that I'm looking for, that I'm hoping that you will find, is what we mentioned earlier, actually, when I said this is a transversal crossing parallel lines. We know that alternate interior angles formed by a transversal crossing parallel lines are congruent. I could also mark these two angles here, this one and this one. Further, we could say that an angle is congruent to itself by the reflexive property. So this angle is congruent to this angle in both the large triangle and the small triangle. In any case, by the angle-triangle similarity theorem, when I know that I'm going to have two angles that are congruent at all times, then I will know that I will always have similar triangles. And this was what I was trying to get out of students in this lesson at this point, to write the conjecture, to justify it to a skeptic. We know that a transversal crosses parallel lines to form congruent corresponding angles. The corresponding angle theorem says if two lines are parallel, then the transversal crossing those lines forms congruent corresponding angles. You could also say that angle B in this is congruent to itself by what rule? By the reflexive property. Or you could say it's a common angle, or it's the same angle for both triangles. And now I'm going to give you a demonstration of the side splitter theorem. And actually, for this lesson, I'm not going to give the demonstration. I'm going to let you watch the video of it. And this explains why it works. Then you can try it if you want. Here we go into the problems. And for each of these problems, I have a video that you can watch after you try it. You should try it first, and then you can look at the solution to make sure that you check your work. And some of these are relatively straightforward and easy. A few of them get a little bit harder. And this one is considerably harder, but it's still doable. And it's asking you for more things. You'll notice this AB splits side ED and EF, but it doesn't say anything about AB or EF. It's a side splitter theorem problem, but it's also dealing with the similar triangles. And then we have this problem, which is like side splitter on overdrive. So I do give you a solution to it. I have a video posted that you can watch down at the end. And the synthesis and then the cool down. So good luck and success.